Hello, ladies and gentlemen of Trig. This is Mr. Heeren, talking to you about 4.3 and 4.4 combined. So we're going to talk a little bit about angle addition and a little bit about what's considered a double angle and kind of how that works within the idea of trig. So let's kind of talk a little bit about here. So think about this a little bit. Does sine, cosine, tangent, do those functions work like other variables? And saying, can I just distribute this and have it work? And in the interest of time, I'll kind of shorten up some things. Combining these two would be the sine of pi over 2. Okay, so pi over 6 plus pi over 3. That's pi over 6. This would be 2 pi over 6. So 3 pi over 6, which would just be pi over 2. So sine of pi over 2, if you look at your unit circle, that's right up here. That's going to be 0, 1. So that answer is going to be 1. Down here, sine of pi over 6, if you look at your unit circle, pi over 6, this would be square root of 3 over 2, 1/2. So that's going to be 1/2. Then remember, pi over 3 is just flipped. So it looks like that. So this is actually going to be 1/2 plus square root of 3 over 2. So what does that equal? That equals 1.366. So are these two equal? The answer to that is no. So I can't just distribute that and have it work. Trig functions don't work the way like regular variables do, like we're used to in algebra. Okay, so if it doesn't work like that, how does it work? Well, it ends up working like this. And this is in your trig formula sheet, which, as I said before, this might be one of the few things I actually tell you, you need to print this off. It's in Schoology, and you can use this on any further quizzes or tests. So I would definitely print this off and have this handy. So this is fair game. So let's talk a little bit about back right here that I took. You are being familiar with all of these, and you don't have to memorize them because I'm giving you the formula, kind of what we're doing here. So this I'm going to use to figure out kind of my remaining answers. But all I'm going to do is follow that pattern of sine squared x plus cosine squared x equals 1. That same concept that keeps showing up over and over and over again. So this, cosine is 4 over 5. What's sine, cosine, tangent? So it's sine squared of x plus 4/5 squared equals 1. And, solving this, we've solved this before. This ends up being 3/5. Cosine they give you is 4/5. Tangent, remember, is sine over cosine. So that's 3/5 over 4/5, which just simplifies to 3/4. So there is 3/5, 4/5, and 3/4. And again, all I did was kind of follow this idea to get my answer. That was, so now if I look at the y function, again, I'm going to use sine squared y plus cosine squared y equals 1. So I know that sine is 5/13. Sine of y is going to be 5 over 13. So that's squared plus cosine squared y equals 1. And then, cosine squared y ends up equaling 144 over 169 once I square it. I skipped a few algebraic steps, and I can show you those if you really want to. But you end up with that being 12 over 13. Now, tangent, remember, is sine over cosine. So that's going to be 5 over 13 over 12 over 13. So multiply top and bottom by 13. You get 5 over 12 is going to be your answer. All right, so tangent is that, cosine is that, sine is that. So now, this thing, let's kind of finish this up. So secant, remember, is 1 over cosine So that's going to be like 1 over 4/5. So that's going to be 5 over 4. Cosecant, remember, is going to be 1 over sine of y. So that's going to be 1 over 5 over 13. So that's going to be 13 over 5. So cotangent of y, remember cotangent is tangent flipped over. So cosine of y is going to be 12 over 13. Sine of y, 5 over 13. So that just simplifies down to 12 over 5. Okay, so all I'm doing, kind of substituting that in and then going from there. Your formula. So when you look at starting to add these two, what does that look like? So remember, sine of x plus y is really sine of x cosine of y plus sine of y cosine of x. So what might be helpful up here, if you have the cosine of x, remember the sine of x is going to be 3/5. Sine of y is 5 over 13, so cosine of y is going to be 12 over 13. So now what does this look like? Well, the sine of x is going to be 3/5. Cosine of y is going to be 12/13, plus sine of y, which is going to be 5/13, cosine of x, which is going to be 4/5. So now, good news is that when I do this, I'm going to end up with the same denominator, which makes life easy. So I'm going to add those two. That becomes 12. So my final answer becomes 56 over 65. Okay, so then cosine ends up being cosine x, cosine y, minus sine x, sine y. So same kind of idea, cosine x, 4/5, cosine y, 12/13, minus sine of x, 3/5, sine of y, 5/13. So this becomes 48 over 65 minus 15 over 65, which should give you 33 over 65. So tangent of xy, if you look back at your sheet, is going to be sine of x plus y over cosine of x plus y. So that would be 56 over 65 over 33 over 65, which just simplifies to 56 over 33. All right, so all of these came from my cheat sheet. All of these came from a sheet that you need to be aware of. All right, so what one does this really look like? Well, adding sine of this and this is really, so if I consider this x, consider this y, it's almost saying like sine of pi over 6 cosine of pi over 3 plus cosine of pi over 6 sine of pi over 3. Okay, so it's that sine of x plus y is sine x cosine y plus cosine x sine y. So now when you look at your unit circle, okay, or if you kind of sketch it, pi over 6, pi over 3, this becomes square root of 3 over 2, 1/2. This becomes the short one, the pi over 6 becomes 1/2 square root of 3 over 2. So what happens when you end up doing that is taking 1/2 times 1/2 plus square root of 3 over 2 times square root of 3 over 2. So that becomes 1/4 and 3/4, which just gives you 1. Okay, that's all you're looking at. So I'm going to use them. Does that change if I go subtraction? So this becomes subtraction, where now you're going to go sine x cosine y minus cosine x sine y. So now you got sine, so this is like your x, this is like your y. So you go sine of pi over 6 cosine pi over 3 cosine pi over 6 sine pi over 3. And I'm using my unit circle. So if you have your unit circle, that would be very handy. So you're going to go 1/2, 1/2. And this becomes square root of 3 over 2, square root of 3 over 2 multiplied together. So it gets you 1/4 minus 3/4, which is going to give you negative 1/2 when you simplify it. All right. So one more kind of idea of thinking, how can I do this? Simplify sine of 15 using either angle addition or subtraction. This is where you might have to get a little bit clever and realize that 15 is nothing more than 45 minus 30. So I can consider sine of 15 to be represented by sine of 45 minus 30. So then it becomes a sine of 45 cosine of 30 minus cosine of 45 sine of 30. And depending on what your memory of unit circle is, 45, remember, is going to be square root of 2 over 2, square root of 2 over 2. And then for 30, for pi over 6, remember that ends up being square root of 3 over 2 and 1/2. Okay, so when I put this together, I'm going to have square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2 times 1/2. So that becomes square root of 6 minus square root of 2 all over 4. And I'd leave it like that. I don't want to calculate it out to make a big mess. But what's important, all right, so jumping ahead, let's talk a little bit about double identities. Can I just, before we talked about can I distribute, now we're asking, can I just, are those two going to be the same? Can I just double the sine of 30 to get sine of 60? Well, sine of 60, 60 is going to be 1/2 square root of 3 over 2. So that's going to be square root of 3 over 2. Sine of 30 is 1/2. So this is saying like 2 times 1/2, which is just going to be 1. Those two are not equal, so no. So I can't just double a short one to get the next size up, okay? I can't just double 30 to get to 60. It doesn't work like that. So this is another group of formulas that are going to be on your formula sheet that you don't have to memorize them, but you do have to understand how to use them. Sine and cosine are especially useful when kind of dealing with the double angles. So if you look, trig formulas. So if sine is 1/2, again, I'm using sine squared plus cosine squared equals 1 to solve that. And this is stuff from chapter 2. So cosine x, that's going to be just 1/2 squared plus cosine squared x equals 1. So cosine squared x is 1 minus 1/4. So cosine ends up square root of 3 over 2. So we know it's in quadrant 1, so we know it's positive. Sine of y, y is in the third quadrant. So again, same idea. I've got negative 3/5, but it's still kind of the same thing. So I got sine of squared y plus negative 3/5 squared equals 1. Doing some algebraic maneuvering, you end up with 16 over 25. So when I square root that, I end up getting 4 over 5. But realize I'm in the third quadrant, so that's going to be negative. All right, so kind of keep that in mind. So when I look and start kind of piecing these things together, cosine of x is going to be square root of 3 over 2. Sine of y is going to be negative 4/5. So sine of 2x, if you look on your formula sheet, goes double sine x, cosine x. So I'm going to take 2, sine of x is 1/2, cosine of x is square root of 3 over 2. So multiply all that together, you get square root of 3 over 2. 2 and that cancels out. You're just left with the other one. Cosine of double x, and this is the one that always is odd to me, that the first thing you're doing is squaring it instead of multiplying it by 2, is this. So cosine squared x, so square root of 3 over 2 squared, minus sine squared of x minus 1/2 squared. So you end up with 3/4 minus 1/4. So you're going to get 1/2 as your answer. The last one, sine of 2y. Sine didn't change, or double sine of 2y didn't change. So you're going to go 2 sine y cosine y. So you're going to go 2 negative 4/5 negative 3/5. So multiplying all that together, you end up with 24 over 25 positive. That's your answer. All right, so sine 60 does not equal 2 sine 30. What does sine of 60 equal? So remember, the sine of 60 is, we're looking at sine of 2 pi, or not 2 pi, 2 theta. Sorry, I don't know why I keep calling it pi. So you want sine of 2 times 30. So you want 2 sine of 30 cosine of 30. So that's going to be 2 times 1/2 times square root of 3 over 2. And again, these I'm getting from either just drawing out the sine of 30 or just using my unit circle, which, I told you guys, you're going to have to get really good with your unit circle. So I'm hopeful that you listen to that. So sine of 60 actually equals square root of 3 over 2. But that's something we knew. So kind of working backwards, simplifying this, you have 2 sine of 35 cosine 35. So remember, that's going to be equal to the sine of 2 theta. Here our theta is 35 degrees. So this is saying the sine of 2 times 35. So this is actually the sine of 70. Similar over here, this time theta is going to be 22. So it's going to be sine of 2 times 22, or sine of 44. That's going to be my answer. Okay, so it's about recognizing that pattern and working backwards. Okay, so here's kind of your double angle formulas for sine and cosine. Again, you don't have to memorize them, but just be aware of them. And then looking for tangent. What am I looking at here? Well, 2 tangent of theta, or 1 minus tangent squared of theta. So here, theta is going to be my 5x. So it's a tangent of 2 times 5x. So this is really the tangent of 10x right here. Similar pattern here. Theta is going to equal 13x. So it's really tangent of 2 times 13x. So you're looking at the tangent of 26x. Okay? So you should be able to use both of those. So for 4-3, let's check off a couple. Let's cut off that one and that one. Cut off 9 and 12 for 4-3. And then we will cut off 16 and 17. And then see what you can do with those 3. I think you guys can do it. Play around with that a little bit and see how you do. For 4-4, they give you these, sine and cosine, and then you got to do some work with the double angle. We'll skip that one. And skip 5 and 6. Then on the back side, skip secant and skip 20. Okay, that's what you're working on, 4-3 and 4-4 combined. Have your formula sheet, have your unit circle when you do this.